Hello, ASVAB warriors. Welcome to the next session of General Science. We had already seen two videos based on the topic matter and its properties. If you haven't seen yet, please do visit our channel and check those videos. So this is the third session for matter and its properties. Okay, so let's continue. As the title of the slide says, mixture and pure substances. When we are using word pure, what it means is it is not containing any other matter but only one kind of component, right? And when we are saying mixtures, that means it is containing one, two, or three multiple number of components which are mixed physically to get that particular substance. So mixtures, two and more substances physically combined. When we are saying physically combined means if this is substance 1 and this is substance 2, if I mix them by using agitator or even by hand, then what I get is mixture of these two substances where few particles are of the dot kind of a substance and few particles are of square kind of a substance. It can be a homogeneous mixture or heterogeneous mixture. When we are saying homo, the word homo means when they are same or similar. If they are of single kind or single type, whether it is in shape or chemical nature, then such is called as homogeneous mixture. When you are not able to check out that it is different, two different elements are there or materials are there, then it is called as homogeneous mixture and we often call it as solution. Example, salt water is homogeneous mixture because we are not able to see any difference in sea water or tap water. Both are containing salts, but these are properly mixed into water. Salts are properly mixed into water and we are not able to identify them separately. So it is called as homogeneous mixture. And when with the physical examination or with your eyes, you are able to see there are differences in the particle size, in the color of the material or mixture, then we call it as heterogeneous mixture. Like in case of salad. Salad is containing broccoli, it is also containing cabbage, it is containing pieces of carrot. So these are different colors, different sizes, and we are able to identify them differently, even though they are in the same bowl. Hence, it is called as heterogeneous mixture. When we are saying pure substances, then these are consisting of only one type of particle. In earlier case, what we have seen, there are multiple kinds, either two or more kind of materials mixed together, then it is called as mixture. When we are talking about pure substances, it is always of one type. Can be element, single element could be there. For example, it could be ferrous, it could be gold, it could be silver, it could be copper. A single pure metal or element is also example of pure substances, or it could be a compound which is chemically throughout same. If you take water in a beaker, water at the top side will be same chemically as the water at the base. It will be always H2O, which is two atoms of hydrogen and one atom of oxygen. If you take sample from the top side or from the bottom side or any place in the beaker, it will be chemically always H2O, two hydrogen and one oxygen. It will not be something else in a corner or at any place in this particular beaker. So such are called as pure substances. This could be either single element or individual element, metals, non-metals or metalloids, or it could be a substance which is a compound like water. Even sugar is a compound. If you take any sample from a bag of sugar or container of the sugar, it will be always sugar. It will be always sucrose. The formula is C6H12O6. It will not be different. So, what we learn from this slide is mixtures are physically combined substances. Those could be homogeneous if they are of the single kind, or you are not able to trace any difference into it, or it could be heterogeneous when they are appearing different from one another. Other thing is pure substances. They could be single element or they could be compounds, but throughout they are of the same chemical nature. As you can see in the picture as well, that elements, compounds, homogeneous and heterogeneous is shown with the different arrangements that would be easy for you to understand. We will move on to the next slide. Okay, ready for the question? If you already know the answer, you can type in the chat box. Which of the following is an example of pure substances? Salt water, air, iron, salad and sand. So here salad we had already seen that it is not a pure substance. So this is not our answer. Air, as you know, it is mixture of different gases. Again, it is not a example of pure substance. Salt water, it is also containing salt and water. Two components are there. So this is also eliminated. Then sand. Sand is made up of different minerals and it is majorly made up of silicon dioxide. So again, it is a kind of a mixture. So this is not our answer. Right answer is iron, which is element, pure element. Ferrous is there. So the right answer is iron. Okay, we will move on to the next slide. Again, we are coming to compounds mixture. So we will see in detail. Elements, simplest form of matter, which cannot be further broken down by chemical means. If I take element hydrogen, whether it is having 2000 atoms into that particular space, so chemically each of these 2000 hydrogen atoms are same. They are not broken down again into simpler part. Like we cannot do half of hydrogen or 1/4 of hydrogen, or it will not give rise to any other material. So the simplest and basic unit of an element, of an material or substance, right? So this is called as element. The simplest one is atom of that particular element. Next is compound. These are made up of two or more elements. Those are chemically combined. Like example is H2O. Even sulfur dioxide is another example. Carbon monoxide is one of the example. Then there is O3, where 3 oxygen atoms are combined, right? So here this is also a kind of a compound. This is homogeneous kind of a compound where all the atoms are of the same type. Then next is mixture. These are physically blend of two or more compounds. If you separate them, even by physical means, you can get different fractions. From air, we can separate carbon dioxide, we can separate oxygen, we can separate nitrogen by employing different methods of separation. As you can see that when I am writing here CO2, O2 and N2, these are chemically different materials. Hence, we call them as mixture because they are different in nature, they are not chemically same. So mixtures, as you can see from the picture, few are triangles, few are this shape, circle, right? So all this when mixed together by a physical mixture, not chemically bound to each other, then it is called as mixture. When the substances are bound chemically to each other, then it is called as compound. Like carbon dioxide. One carbon atom is combined with two oxygen atoms, so it is a compound. Element is a pure substance. You take an example of gold, copper, aluminium, or ferrous, hydrogen, helium. So these are elements. These are pure substances. Just a quick revision. Elements, compounds and mixtures. Elements are the simplest form which cannot be broken down by chemical means. Compounds are, these are chemically combined with each other. It could be of same kind or different kind of elements. And mixtures are physically blend with each other to form that particular mixture. Next is law of conservation of mass. In the universe, whatever material is there, it will be overall, if you take universe, it will be always constant. It is neither getting destroyed nor it is getting made or created. It is always there in one or another form. So what this law says, mass is neither created nor it is destroyed in chemical reaction. We are only talking about a chemical reaction right now. So total mass of the reactant will be equal to total mass of the product. If there is a chemical reaction going on, then what happens is, whatever you are taking, if suppose from the picture we are seeing that there are two hydrogen molecules, this is 1 and this is 2. It is combining with one oxygen gas molecule, which is containing 2 atoms of oxygen. What we get is 2 molecules of water. So if we count here, there are 4 hydrogen atoms and here there are 2 oxygen atoms. In the product, how many are there? Again the same, 2 oxygen and total 4 hydrogen. So there is LHS is equal to RHS. Whatever reactant we have taken, it is same as in the product, even though there is a chemical reaction already done, right? 2 different substances combined to give us water. So it is always the case, we should be balancing the chemical substances on both the sides. Reactant are always equal to product. In chemical reaction, it could be there that you are adding reactant 1 and reactant 2 to get product 1 and product 2 plus product 3. It could be any number, but it is always the case that this summation is always equal to the summation of the products. So again, what is law of conservation of mass? Mass is neither created nor destroyed in a chemical reaction. Total mass of reactant is always equal to total mass of the product. We will move on to the next slide. So matter exists in different states and has various physical properties. This is just a summary of our total videos based on matter and its properties. Examples are air, water, rock, and humans. What are the states of matter? Solid, liquid, and gaseous. These are the 3 states. But when there are 2 states which are coexisting, it is also called as plasma and physical changes are changes that affect the form of a chemical substance, not the chemical nature, right? So it is melting, freezing, and dissolving or cutting into small pieces. Chemical changes are when there is change in the chemical nature of the material. Earlier it is something else. After the chemical change, it has changed its structure. Burning of a substance, rusting of iron, digestion of food that you are consuming. What are mixtures? Two or more substances physically combined, which can be homogeneous or it could be heterogeneous. Pure substances, when we are having a substance, either single element, individual element, or a compound, but throughout it is same, then it is called as pure substance. What is law of conservation of mass? Mass is neither created nor it is destroyed during a chemical reaction. So reactants are always equal to the products. The total mass is always constant. Question time. Which law states that mass is neither created nor destroyed in a chemical reaction? If you know answer, please write down in the chat box. First option is law of definite proportion. Second is multiple proportion, conservation of mass, conservation of energy, and constant composition. Here, the statement says that it is neither created nor destroyed, but we are talking about mass. So here, answer is option C, law of conservation of mass. This is the end after the summary of the topic. So please check part 1 and part 2 of the same topic. There is a study material provided for the same topic as well. Thank you so much.